Hi everyone, so this is our first video in this new unit that we're in. You'll see on Schoology we're calling this Unit 4, but when you're using the Big Ideas textbook or the Big Ideas practice, you're going to notice that it's actually Chapter 5. Okay, so that's why I kind of wanted to start this new Unit 4 with this video, just chatting about it, and then this is going to be in Big Ideas Chapter 5. So this is Section 5.1 actually in our textbook. We're calling it Unit 4 because it's the fourth unit we're talking about. And this unit is all about congruent figures, specifically triangles. So I thought we'd just go over some basic types of triangles to start. So there's two different ways that we can classify triangles. We can classify triangles by their sides. That's the first one. So, and if you want to make note, we've got three different types of triangles here on the screen. We've got a scalene triangle. That's this one. Scalene triangle has no congruent sides. There's nothing that's similar when we're looking at a scalene triangle. The sides, this could be 3, this could be 4, this could be 5. Sides are all different. They're not congruent. In an isosceles triangle, we've got two congruent sides. Notice the tick marks. So I know that this side is congruent to this side. The lengths are the same. And in an equilateral triangle, equal, right? That's what kind of like this sounds like. The three sides are all congruent. That's an equilateral triangle. That's how we're going to name triangles by their sides. We can also give them another name. Each triangle can have two names. And this one's classifying it by angles. So let's take a look at these. An obtuse triangle only needs to have one obtuse angle. So this angle right here would be obtuse. That's what makes this an obtuse triangle. The next one is an acute triangle. It needs to have three acute angles. All three of these angles need to be acute for us to call it an acute triangle. Then we've got a right triangle. All we need is just one right angle, and we'll see that little box here to identify that this is a right triangle. And then we have an equiangular. So again, equal, there's that word angle. We've got three congruent angles, and actually they're all going to be 60 degrees. So we'll learn that pretty quickly. If it's an equiangular triangle, boom, right away I know all three angles are 60 degrees, always. Something else we want to note here, guys, is that if it's an equilateral, it's also equiangular and vice versa. So those two will always go together. Equilateral means it's an equiangular triangle, and equiangular triangle means it's an equilateral triangle. Some more vocab here. We're going to see, we're going to talk about interior angles and exterior angles, and it's pretty much what it sounds like. Interior angles are on the inside, so here's interior angles. Interior angles, my handwriting's sloppy when I'm doing it like this. And exterior angles, they're on the outside of the triangle, formed by if we took the sides of a triangle and just extended it. So it's formed by a side of the triangle and then an extension of the other side. Here are exterior angles. Just to kind of be familiar, if we talk about where to look. So interior on the inside, exterior on the outside. So we've got some theorems here to chat about. The first one is the triangle sum theorem. The triangle sum theorem we are going to reference all year long. It says the sum of the measures of the interior angles of a triangle is 180 degrees. Guys, every single time, it doesn't matter if I draw a triangle that looks like this, doesn't matter if I draw a triangle that looks like this, or a triangle that looks like this. If I have angle 1, angle 2, angle 3, or angle 1, angle 2, and angle 3, or angle 1, angle 2, angle 3, guess what? When I do the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3, every single time it's going to equal 180 degrees, and we have to get that in our brains. The sum of the three angles of a triangle always add up to 180 degrees. Okay. The next theorem that we're going to talk about is the triangle exterior angle theorem, which we're going to use a little bit. This says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So what the heck does that mean, right? Let's get a picture. If I have a triangle and I have an exterior angle, sorry guys, the measure of an exterior angle right here, let's say that's angle 1, is equal, so the measure of angle 1 is equal to the sum of the two angles that are not adjacent, which means next to, so not next to the interior angle here. Okay, so we find the exterior angle, it equals the sum of the two interior angles that it's not next to. And then the last theorem here, it says that the acute angles of a right triangle are complementary. And this kind of makes sense, guys. If I have a right triangle, that means this is 90 degrees, right? That means the other two angles, complementary, what's complementary mean again? Hopefully you remember it adds up to 90 degrees, which makes sense because we know all three of these angles add up to 180, right? So if all three of these angles add up to 180, this one I know is 90, the other two have to add up to 90. That's this last theorem. So guys, we're just going to practice these theorems. Here's our first problem. It wants us to find the values of x, y, and z in this diagram. First thing that I'm going to look at here is this triangle, that little one. I'm looking at that triangle because notice I already know two angles in this triangle. I know this angle is 59 and then this one's 43. So I know x because I know that if I add up all three of these angles, 43 plus 59 plus x, because I don't know what it is, they have to always add up to 180. So we're just going to solve that little equation, and I'll combine my terms and then subtract it over, and we should get x equals 78. Okay, so there's that first variable. Right here now I know that this is 78 degrees. We can go a couple different places from here. What I notice is I've got a linear pair right here. We know if I have a straight line, the degrees on a straight line is 180. So if I take 180, subtract 78, that's going to give me y, which is 102. Okay, so this straight line has to equal 180. If I know straight line equals 180, if I know a piece of it's already 78, part plus another part equals the whole. So I could do 180 minus the 78 to give me the other piece that's left over. And then once I know what y is, I can now focus on that other triangle, right? Because once again, now I know this angle of this triangle, this angle of the other triangle, so I can use the 180 to find z. So I know those three angles have to add up to 180. 49 plus 102 equals z. Combine like terms, subtract it from the 180, and we get 29 equals z. Okay? The next problem here, it says the measure of one angle of a triangle is 105 degrees. I don't have a picture. It's really helpful to always draw a picture right away. So I know it's going to be 105, so that's why I drew a obtuse triangle. So I've got the obtuse angle there is 105. The other two angles are in the ratio 1x to 2x. So I don't know what they are, but I know that one is doubled, right? So if one is 5, the other is going to be 10. I set up this picture because that helps me remember, oh, three angles of a triangle add up to 180. So I could do x plus 2x plus 105 equals 180. And then I just combine like terms. It'll give me 3x plus 105 equals 180. I'll subtract the 105 over, and then I'll divide by 3. So I can find x. We have to be careful and read the directions. It says what are the measures of the other two angles. So now I know that this one is 25, and this one here is 2 times 25. So it's 50 degrees. Those are my answers. Okay. The next one, it says, it has us practicing that exterior angle theorem, where it says if I have an exterior angle, it equals the sum of the two interior angles non-adjacent to this interior angle number 1. Let me just solve that. Combine like terms. I'm going to subtract the 3x over. I'm going to add the 10 over. And I get x equals 25. Again, find the measure of angle 1. We're going to take that 25 and substitute it right in. And we should get 115. Okay, a couple more things that we're going to chat about here. Review on polygons. So remember, a polygon is a 2D closed figure with all straight sides. Really important that we notice it's all straight sides, because then when I look at problem 4, these examples, yes, this is a polygon. No, this is not a polygon. Look, it's a curved side, so it's not a polygon. And then this one's, no, it's not a polygon because it's open, right? It can't be a polygon. Here are some names of polygons. We have to be able to classify them. So you can jot this down. Make sure you know, okay, if it's got 5 sides, it's called a pentagon. 7, septagon, or heptagon. Those, you'll see both of those. If it has more than 10 sides, we call it an n-gon. And we place n with how many sides it has. So for example, if it has 13 sides, we just call it a 13-gon. A little bit more vocab here. Convex polygon has no angles pointing inwards. So this right here is a convex polygon. If there's an angle pointing inwards, like this angle right here, see how it's pointing into the triangle? It's called a concave polygon. Give you a moment if you want to pause and jot that stuff down. And then I've got some more vocab. Familiar though. So we've talked about an equilateral triangle has 3 congruent sides. An equilateral polygon has all sides are congruent, and you can see the tick marks there. Equiangular polygon, all angles are congruent, and you can see these angle markings. A regular polygon is the most perfect polygon we can have. It's both the sides and the angles are congruent, everything. So everything has to be noted. See how the angles are all congruent and the sides are all congruent. Same thing here. Has to have both. And this would be called an equilateral and equiangular polygon. When we name a polygon, you just pick any vertex, which is a point, a corner, and you either go clockwise or counterclockwise. You just have to go in order. So I can call this polygon A, B, C, D. I could call it B, C, D, A. I could start at D and go backwards, D, C, B, A. I just can't jump around. I can't go A, C, B, D. Can't do that. It has to be consecutive. And then here are some examples of polygons. Convex pentagon. All of the angles are pointing outside and it's got 5 sides. A regular convex hexagon. Regular because it's got both congruent sides and angles, and then you can count the sides. It's a hexagon. This one's not a polygon. It's a circle, right? There isn't a straight side. It's one curved line, one curved segment, so it's not a polygon. Concave octagon, it's pointing inwards. Equilateral, because all I know are those sides are congruent. And then convex, they're pointing outwards. Quadrilateral, it has 4 sides. And then just something to think about here, name a shape that's equiangular, like a rectangle. Look, all 4 right angles. But it's not equilateral, right? These 2 are congruent and then these 2 are congruent. Just something fun to think about. All right, guys, great job. Thank you for watching this. This is the first section in Unit 4. That's what you'll see on Schoology, but it is section 5.1, Chapter 5 in Big Ideas. Great job, guys.